Welcome to Astronomy Daily, your cosmic connection to the stars and beyond. I'm Anna, and today we have an absolutely stellar lineup of space news that you won't want to miss. We're diving into what scientists are calling the strongest evidence yet for life beyond our solar system, a discovery that could fundamentally change our understanding of our place in the universe. We'll also explore why the Bahamas has suspended SpaceX landings, and take you on a journey to a newly discovered planet that orbits two stars in a configuration previously only seen in science fiction. Plus, does the entire universe rotate? A new theory suggests it might, and this could solve one of astronomy's biggest puzzles. And finally, we may have cracked the six-decade mystery of where the most powerful particles in space come from. So, strap in as we journey through today's cosmic headlines and explore the wonders waiting for us among the stars. Let's get started. In what might be the most exciting astronomical discovery in recent years, scientists are reporting what they describe as the strongest evidence yet for extraterrestrial life beyond our solar system. A team of astrophysicists, led by Professor Niku Madhusudan from the University of Cambridge, has made observations using the James Webb Space Telescope that could bring us closer to answering humanity's age-old question: are we alone in the universe? The observations focus on a planet called K218b, which is located 124 light-years away from Earth in the Leo constellation. This planet is significantly larger than Earth, nearly 9 times as massive and 2.6 times the size, and orbits in what scientists call the habitable zone of its star, a cool red dwarf that's less than half the size of our Sun. What's truly remarkable about these findings is the detection of two chemical compounds in the planet's atmosphere: dimethyl sulfide, or DMS, and dimethyl disulfide, or DMDS. What makes these chemicals so significant is that on Earth, they're primarily produced by marine phytoplankton microscopic marine algae. In other words, they're biological in origin. Professor Madhusudan describes this as potentially a tipping point in our search for extraterrestrial life, telling reporters, "Decades from now, we may look back at this point in time and recognize it was when the living universe came within reach." The scientific team is being appropriately cautious, however. The findings, published in the astrophysical journal Letters, report the signals with what's called 3 sigma significance, meaning there's about a 0.3% probability they occurred by chance. While impressive, this falls short of the gold standard for discoveries in physics. There are also important questions about whether K218b's overall conditions are favorable to life. The Cambridge team suggests the planet could be covered by a vast, deep ocean, potentially making it the most habitable known world beyond our solar system. But other scientists dispute this interpretation, suggesting it might be a gas planet or have oceans made of magma rather than water. Dr. Nora Hani, a chemist at the University of Bern who wasn't involved in the study, points out that there might be alternative explanations for the presence of these chemicals. Life is one of the options, but it's one among many, she notes, adding that we would need to rule out all other possibilities before claiming definitive evidence of life. Dr. Jo Barstow from the Open University shares this skepticism, saying her skepticism dial for any claim relating to evidence of life is permanently turned up to 11. She clarifies that this isn't because she doubts extraterrestrial life exists, but because such a profound discovery requires an extraordinarily high burden of proof. At 124 light-years away, we won't be sending probes to K218b anytime soon to confirm these findings. But as Professor Madhusudan points out, astronomy has never been about physically visiting distant objects. We're trying to establish if the laws of biology are universal in nature, he explains. I don't see it as, we have to go and swim in the water to catch the fish. If confirmed, this discovery would represent a monumental shift in our understanding of life in the cosmos. Even as a tentative finding, it provides compelling evidence that the chemical signatures of life may be detectable on distant worlds, opening new frontiers in our search for extraterrestrial neighbors in this vast universe. Next up today, some not-so-good news for SpaceX. The Bahamas government has announced a significant suspension of all SpaceX Falcon 9 rocket landings in the country, pending a comprehensive environmental assessment. According to Bahamian Director of Communications Latrai Raming, no further clearances will be granted until a full environmental assessment is reviewed. This decision marks a sudden halt to what had been an expanding relationship between the Caribbean nation and Elon Musk's private space company. Just 2 months ago, in February, the Bahamian government had approved 19 more landings throughout 2025, all subject to regulatory approval. Now, those plans have been put on indefinite hold. The suspension follows a concerning incident last month when a SpaceX Starship spacecraft exploded in space minutes after lifting off from Texas. Social media videos captured fiery debris streaking through the skies near South Florida and the Bahamas after the spacecraft broke up in space. According to Bahamian officials, debris from the spacecraft fell into the country's airspace, though they stated the debris contained no toxic materials and wasn't expected to significantly impact marine life or water quality. It's important to note that while this suspension directly affects the Falcon 9 landing program, the incident that prompted the review involved SpaceX's larger Starship vehicle. The Starship program is separate from the Falcon 9 operations that had been taking place in Bahamian territory. This development highlights the growing complexity of managing space operations as private companies like SpaceX dramatically increase the frequency of launches and landings. The Bahamas, with its proximity to U.S. launch sites and relatively sparse population, had emerged as an attractive location for SpaceX's expanding operations. For SpaceX, this suspension creates a significant logistical challenge. The company has been working to increase its launch cadence and relies on successful rocket recovery to maintain its reusable rocket business model. Finding alternative landing sites or adjusting mission profiles could impact the company's launch schedule and costs. The incident also draws attention to broader concerns about space debris and environmental impacts as space activities increase globally. While space agencies and companies have long addressed the issue of orbital debris, the potential for launch failures to affect territories beneath flight paths is becoming a more pressing regulatory concern. As space activities continue to grow and diversify, countries like the Bahamas are establishing their own regulatory frameworks to balance economic opportunities with environmental protection and safety concerns. This incident may well serve as an important precedent for how nations handle the complex relationship between commercial space operations and their own sovereign interests. If you're a fan of Star Wars, this next story is for you. You're probably familiar with the iconic double sunset seen from the planet Tatooine. While that seemed like pure science fiction, astronomers have actually discovered several planets orbiting binary star systems over the years. But now, they've found something truly unprecedented that pushes our understanding of planetary systems even further. A team led by Thomas Baycroft, a PhD student at the University of Birmingham, has discovered an exoplanet with a configuration never seen before. This planet, named 2M1510 AB-B, orbits not just any binary star system, but a pair of brown dwarfs. Objects that are larger than gas giant planets, but too small to be proper stars. What makes this discovery particularly remarkable is the planet's orbit. Unlike previously discovered planets around binary stars that typically orbit in roughly the same plane as their host stars, this planet follows a path that's perpendicular, at a right angle, to the orbit of its two host stars. I am particularly excited to be involved in detecting credible evidence that this configuration exists, said Baycroft about the discovery published in Science Advances. His colleague, Professor Amori Trio, added that a planet orbiting not just a binary, but a binary brown dwarf, as well as being on a polar orbit, is rather incredible and exciting. The discovery was actually serendipitous. The team wasn't specifically looking for such a planet when they made their observations using the ultraviolet and visual Echelle spectrograph instrument on the European Southern Observatory's Very Large Telescope in Chile. They were actually studying the brown dwarf pair, known as 2M1510, which is only the second pair of eclipsing brown dwarfs ever discovered. While observing the orbital path of the two brown dwarfs, the astronomers noticed something unusual. The stars were being pushed and pulled in ways that couldn't be explained by their interaction alone. After reviewing all possible scenarios, they concluded that the only explanation consistent with their data was the presence of a planet orbiting on a polar axis. This discovery is significant because while theoretical models had suggested such configurations were stable and planet-forming disks on polar orbits around stellar pairs had been detected, we lacked concrete evidence that planets could actually form and persist in such arrangements. It opens up new possibilities for understanding the diversity of planetary systems and challenges conventional theories about how planets form. As Professor Trio noted, the discovery was serendipitous in the sense that our observations were not collected to seek such a planet or orbital configuration. As such, it is a big surprise. Overall, I think this shows to us astronomers, but also to the public at large, what is possible in the fascinating universe we inhabit. While we're reporting on surprising discoveries, what if everything in the universe is spinning, not just galaxies and planets, but the entire cosmos itself? A groundbreaking new study published in monthly notices of the Royal Astronomical Society suggests this might actually be the case. Researchers, including Istvan Sapudi from the University of Hawaii Institute for Astronomy, have proposed that the universe may indeed rotate, just extremely slowly. How slowly? They estimate it might complete a single rotation once every 500 billion years, which would be far too gradual for us to easily detect. This seemingly simple idea could help resolve one of astronomy's most persistent puzzles, the Hubble tension. This problem emerges from the fact that we have two different methods of measuring how fast the universe is expanding, and frustratingly, they give us different answers. One method examines distant exploding stars, or supernovae, to measure the expansion rate over the past few billion years. The other technique analyzes the cosmic microwave background radiation, essentially the afterglow of the Big Bang, to determine how fast the very early universe was expanding some 13 billion years ago. The discrepancy between these two measurements has left astronomers scratching their heads for years. Sapudi's team took a novel approach. They developed a mathematical model of the universe following standard cosmological rules, but with one key difference. They added a tiny amount of rotation. As Sapudi explains, much to our surprise, we found that our model with rotation resolves the paradox without contradicting current astronomical measurements. The idea draws inspiration from the Greek philosopher Heraclitus of Ephesus, who famously said panta rhei, everything moves. Sapudi's team thought perhaps panta kyklutai, everything turns, might also be true. What's particularly compelling about this theory is that it doesn't violate any known laws of physics. It simply introduces a subtle cosmic spin that affects how space expands over time in a way that could explain our conflicting measurements. The next steps for researchers will be to develop a full computer model based on this theory and identify ways to detect signs of this slow cosmic rotation. If confirmed, this could fundamentally change our understanding of the universe and how it has evolved since the Big Bang. We're on a bit of a roll today with new discoveries, so let's throw one more into the mix. After 6 decades of mystery, scientists may have finally solved one of the universe's most perplexing riddles, the origin of ultra-high-energy cosmic rays, or UHCRs. These extraordinary particles, which were first discovered in the 1960s, pack energies more than 1 million times greater than what our most powerful particle accelerators on Earth can produce. Until now, their source has remained elusive. Physicist Glenys Farrar from New York University has published a groundbreaking paper in Physical Review Letters that offers a compelling explanation. Her research suggests these incredibly energetic particles are created during the violent merger of binary neutron stars, when two of these ultra-dense stellar remnants collide. According to Farrar's model, the turbulent magnetic fields generated during these catastrophic mergers provide the perfect environment for accelerating particles to these mind-boggling energies. After 6 decades of effort, the origin of the mysterious highest energy particles in the universe may finally have been identified, Farrar notes. What makes this theory particularly elegant is that it addresses several long-standing puzzles about UHCRs at once. It explains the tight correlation between a cosmic ray's energy and its electric charge, a feature that previous theories struggled to account for. It also provides a framework for understanding the extraordinary energy of the highest energy cosmic rays that have been detected in rare events. The theory suggests these particles originate as rare R-process elements like xenon and tellurium, which are synthesized during neutron star mergers. These same mergers also produce gravitational waves, which we've already detected through facilities like LIGO and Virgo. This connection provides a clear path for experimental validation. Scientists can now look for correlations between gravitational wave detections and the arrival of ultra-high energy cosmic rays. They can also analyze UHCR data for the chemical signatures of these R process elements. If confirmed, Farrar's work represents a major advancement in our understanding of both cosmic rays and neutron star mergers. It gives astronomers and physicists a new lens through which to study some of the universe's most energetic and violent phenomena, potentially opening windows into fundamental physics that we simply cannot replicate in laboratories on Earth. Well, that's all for today's cosmic journey. Thank you for joining me on Astronomy Daily. I'm Anna, your host, and I've been delighted to share these fascinating developments from across our universe with you. If you're hungry for more space news and insights, I invite you to visit our website at astronomydaily.io, where you'll find everything related to our show. We offer a newsletter subscription to keep you updated on the latest discoveries, our complete archive of back episodes, easy ways to get in touch with us, and our continuously updating space and astronomy newsfeed that brings you breaking stories as they happen. Connect with us on social media as well by searching for Astro Daily Pod on Facebook, X, YouTube Music, Instagram, Tumblr, and TikTok. Whether you're curious about potential alien life on distant planets, the latest in space exploration challenges, or breakthrough discoveries in astrophysics, we'll continue bringing the wonders of the cosmos directly to you. Until next time, keep looking up and wondering about our extraordinary universe.